To learn about some questions on normal distribution. Let's begin with the first question. Suppose that the particular medical procedure has a cost that is approximately normal with the mean of $19,800 and the standard deviation of $2,900. For a randomly selected patient, use the table of standard normal probabilities to find the probabilities for the following steps or for the following events. Now again, we are going to look at both the methods for finding the probabilities with the table and also with the calculator. The procedure costs 18,000 and 22,000. So our aim is to find the value of the probability. So our aim is to find the probability such that because it is a normal distribution, so the values lying between 18,000 is x and 22,000. Just because this is a normal distribution, so I'm not using z, I'm using x. Normal distribution can be converted into a standard normal distribution using x minus mu divided by sigma. So the same relation, I'm going to write it here. So the first question which I'm solving, I'm going to use some terms here. Now this is given as the mean for the data and this is given as the standard deviation and these are the values of x. So what I'm going to do is I'm going to subtract this mu divided by sigma here. Same thing I'm going to do on the middle value. Same thing I'm going to do on the value given at the extreme right. Minus mu divided by sigma. This gets converted to probability of 18,000 minus mu is 19,800 divided by sigma, which is 2,900, less than, now this is z, less than 22,000 minus mu, which is 19,800 divided by sigma 2,900. That is equal to probability of. Now the value which is in the center is minus 0.62 less than z less than equal to 0.7586. I can also write it as minus 0.62 less than z less than 0.76. Now we have seen that this is one of the familiar forms which we have seen in the first video when we were finding the probabilities or area when the z-scores are given. So we can refer to the table and we can calculate the probability of z for 0.76 minus probability of z for minus 0.62, and the subtraction of both of them gives us the value or the answer for our question. So using the table, probability of z less than 0.76. So I'm going to go to positive table, 0.76, 0.76, 0.7 and 6. So 0.7 is this line and then I need to find for 6, 0.7764, 0.7764. So this value is 0.7764 minus 4 minus 0.62. I'm going to go to negative page, minus 0.6, minus 0.6 is here, minus 0.62, 0.2676, 0.2676. So 0.2676. So this difference gives us the answer for the question. Similarly, if I want to solve the same question using the calculator, now I'm going to find the area from the given value. So I'm going to shift the tab here Then the mean for the question is given as 19,800, and the standard deviation is given as 2900, and we are calculating in between. Let's put the values 18,000, and this value is 22,000, and we calculate. So the area 0.5086. We can see that we are going to get the same result either way we solve it. Either we are using the calculator or we are using the table, we get the same answer. So the result for both the cases equals 0.5086. Only easy thing about this calculator is instantly we can find the value. Similarly, if I go to part B, the procedure costs less than 15,000. Mean is same, standard deviation is same. So this is below 15,000. And I don't want these values. I'm going to remove these values from here. Less than 15,000. So the probability. If I want to rewrite the question, that question can be written as, this B part can also be written as probability of X less than 15,000, and the area which we found is 0.0489. Similarly, if we want to calculate the procedure cost more than 17,250, so probability of Z, not Z, it's X actually, probability of X greater than 17,250. So if I want to put the values here, mean and standard deviation same, and this is going to be above. I'm going to remove this part, above 17,250. 0.8104. So this is going to be 0.8104 is the area. So we have seen that how we can solve the same question using the calculator and also using the table. We have another example, but as you know, the calculator makes it much more simpler. A customer calling a call center spends on an average of 45 minutes, average, so this is mu, on hold during the peak season with the standard deviation of 12, so this is sigma. Suppose these times are normally distributed. Find the probability that the customer will hold for each interval of times more than 54. So probability of X greater than 54 is to be calculated here. Probability of X less than 24 here, and the probability of X lying between these two is something which we need to calculate in this question. Let's use the calculator for calculating the values. Mean for the question is changed to 45 minutes now. Standard deviation is 12 minutes. Now for the first part, it is above 754. 754. Calculate the value. Above 754. Sorry, no, it's not 754, it's just 54. I mixed with the sign there. 0.2266. So 0.2266 is the area for that. X less than, below now. Below 24. Below 24. Calculate the probability, which is equal to 0.0401. Similarly, when it is lying in between we have 24 and then we have 54. Calculate the result, 0.7333. Same questions can be solved using the table also. if I want to calculate, say, first part in the form of, if I'm interested in using the table, let's see how to solve the first question using the table. We have been given in the first part probability of x greater than 54. As I know, x minus mu divided by sigma gives me z. So probability of z. To make it z, I need to apply few steps, which is x minus mu divided by sigma here. Same thing I'm going to do on the other part also. So this is going to convert this x into z greater than 54. Value of mu is 45 in the question. Value of sigma is 12 in the question. So the question gets converted to probability of z greater than 54 minus 45, so 9 divided by 12. So probability of z greater than 0.75. And then we refer to the table to find the probability of z greater than, which can also be written as z less than minus 0.75. So let's refer to the table for minus 0.75. Negative table, minus 0.7, minus 0.7 is this line, 5, 0, 1, 2, 3, 4, 5, 2266. 0.2266 is the value. We can see that we have got the same value here also. So which is equal to 0.2266, which is same as the value obtained. Similarly, we can check for the second question also. For the B part, for part B, probability of x smaller than 24, so this gets converted to probability of x minus mu divided by sigma less than 24 minus 45 divided by 12. So it is equal to probability of z less than 21 over 12, which is equal to probability of z less than 1.75. And then we can refer to the table to find the probability. Thank you.